Alright, as always, we'll start this video and we'll say if you need to stop at any time, feel free to do so to go over any of the parts, try anything on your own, rewind, fast forward, do whatever you need to do. So here we go. The section here that we're talking about is parts of a circle and circumference when given radius or diameter. So let's first give a quick review of the different parts of the circle that we went over in this unit. They are radius, circumference, diameter, and center. Now, some quick definitions. The radius is identified as any distance from the center of the circle out to the edge of the circle. So we could make several radius or radii, which would be the plural, and they're all going to be the same distance. And if we check this here, let me just copy this one, and I were to paste it right over here. Oops, I did change the size. Sorry about that. Let's try this again. We're going to see that it is still that distance from the center. Okay, so all of these are the same distance from the center. They go out to the edge, and the edge of the circle is similar to any other polygon. Remember, a polygon is going to be any type of shape that has straight edges on it. Okay, this would be a type of polygon we call a rectangle. And the outside edge of this one is called the perimeter. But for a circle, the outside edge is called the circumference. So we're talking about this distance here. Let's see how good my circle is today. Oh yeah, it's perfect. Pretty close. All right, so that distance around the outside of the circle is identified as the circumference. Next, we have the distance going from one edge to the other edge, opposite edge of the circle, or we could also say from one edge of the circumference to the other edge of the circumference, going through the center point, which is just very clearly the middle of the circle. And we know that that is the diameter. So any line that goes from one edge of the circle to the other opposite edge of the circle, or the circumference edges, going through the center, and that point in the middle is called the center. Okay? So we're going to scroll down here, and we're going to talk about the relationship that we have between the radius and the diameter. All right? So, no, I did not draw a wagon wheel here, even though it does look like it, but we're talking about the diameter having 2 times the radius in any given circle. So what I did here is I went through and I kind of overdid this center here, but any edge out is considered a radius, or radii again is what is plural, so that's spelled radii. Okay, so that's more than one radius. All right, and we know that when we have this, if I connect one radius from the circumference to the center, and I draw it all the way through the center of the other side, we know we made a diameter, but we also made another radius here. Let me change the color of that. So we made a radius here, and I also made a radius here. We know that 2 radius are equal to the distance of, I'll do this in a different color, or the length rather, of 1 diameter. Okay, so if we were to go through and say that 1 radius here is 3 inches, clearly we know that this one has to be 3 inches because all radii are the same length or distance from the center out to the circumference. We would know that the diameter would be those 2 together. So 2 of those radius have to equal that diameter value. So I know that the diameter in this case is going to be 6 inches. So if you need to go through and pause this real quick to make sure you know exactly what's going on, that's fine. If you need to rewind, that's fine also, but I'm going to scroll on down here. Okay. Therefore, the radius is always half of the diameter in any given circle. So that should make sense, that if I have this radius here, and we talked about this in the past several times, if I take this same formula where it says 2 radius is equal to the diameter, if I want to isolate just this radius, we know anything multiplied by any variable, we can take to the other side by dividing. Okay, we know that the formula to find a radius is going to be equal to half of the diameter. This means half of the diameter. Okay, so in this case, again, let's identify another diameter. We're going to go from this edge to the other edge. And if we identify this entire diameter as 10 feet, we know that there's 2 portions here, right? 2 portions here that are just 2 radii, okay? And we have to split that diameter of 10 into 2 equal parts. So we know that the radius here is going to be 5 feet. Let me change that color. Use a different color. We know that this radius is going to be 5 feet, and this one over here is going to be 5 feet. So let me get rid of everything in here that doesn't really need to be here. Okay, just all these extra radii. So we can make sure all of those are gone. So that's kind of what we have here. All right. So therefore, the radius is always half of the diameter in any given circle. All right, I'm going to scroll on down here. So these are just kind of some general statements to make sure we know exactly what's going on as far as the relationship between the radius and the diameter. I am going to set these all up with an equation just so we get used to seeing that, because those are going to pop up more and more in the future. And we'll solve these with an equation. Most of you will probably be able to look at this and know what they are right away. But if we know that the radius is equal to 6 centimeters, okay, and we're trying to figure out what the diameter is. So let's remember, again, that we have this relationship between radius and diameter of 2 radius equals 1 diameter. My given information here is 6. And this gets plugged right into this radius. 2 times those radius values of 6 equals our d value. Therefore, the diameter in this example will be 12 centimeters. Next one, we're going to set the same thing up because, again, we're finding the radius. I'm sorry, take that back. We're finding the diameter. We're given the radius. So we're going to say 2r, again, is equal to d. Notice I'm not plugging anything in until I actually write the original formula down here. Okay, so I have 2 times the value given of 4.5, which is equal to d. So I know 2 times 4 is going to be 8, and another half of 2 will be 1. So that 8 plus 1 is just going to be 9 equals d, or d equals 9. Another way to think of this is if I've got $4.50 and double it, that equals $9. Money always seems to help a little bit more for all students. Okay. All right. Going the other way. Again, notice I'm going to use the exact same thing to set this up. So watch, I'm going to say 2r is equal to d. This time, notice that the given information, though, is the diameter. So the diameter in this case is 1, and we have 2r on the left side. So we need to isolate that variable. Anything multiplied by the letter, we need to actually divide. So the other side gets divided, and we're left with the radius of 1/2 inch, which should make sense. If we have 1 inch, the radius is going to be half of that diameter amount, so half, or 1/2 inch. Next, again, same formula for the relationship between radius and diameter. So I have 2 radius equals d, or 2 times radius equals d. This time we're given a diameter of 105. So let's plug that straight in. 2r, we're going to divide both sides by 2. And listen, if you got to go off to the side and actually do the long division, that's okay to do. If you want to pause and try to do it real quick before I finish, that's fine. And we know that r in this case is going to be equal to 52.5 feet. Okay, take a look at it, and then we'll move on. Last two things I have for you, I'm going to make the screen a little smaller so we can see them both at the same time. Let's notice that I'm using two different formulas here, but we have something going on here. We've got a c in each one. We've got a pi in each one. By the way, we're going to use 3.14 for pi. Okay. We've got, we have a c in each one, and we have a pi in each one. All that we have left is that 2r in the top one and the d in the bottom one. And remember, this is okay. These are the same formula, and we know they're the same because we know from the previous problems that we did that 2 radius are going to be equal to 1 diameter. So we're just rewriting this formula in a different way so we can actually find what we're looking for with what's actually given. In this case, the radius, in this case, the diameter. So when we go through here, always start these up with the formula. It's going to be a lot easier for you, okay? Because if you start with the formula, all you're doing is plugging in values. So we don't have the circumference in the first one. The 2 doesn't change. If you want to write 3.14 instead of the pi, that's fine. And we're given the radius of 13. So we have some different properties in math. We can multiply this in any order. So if you wanted to do 2 times 13 first and get an answer of 26 and then multiply by 3.14, that'd be perfectly fine. Or if you want to just multiply left to right, that's perfectly fine. But at the end of the day, the final product to find the circumference again, which is the distance around the outside of this circle, okay? To find this circumference, we're multiplying all 3 of these values together. That's going to give us a final product of 81.64 or 81 and 64 hundredths of an inch, or inches, sorry, not of an inch, inches. Okay. Next one, again, we're using this formula down here because we're given the d value or the diameter value in this. Now, could I rewrite this and say, oh, well, this would be 12 and this would be 12, and I use the radius and use this formula up here? Sure, you could do that, but I'm just going to go ahead and use what I have within the problem, okay? All right, so here we go. We have circumference equals pi times 24. And I'm really okay if you leave the units out until you get to the final answer. I'm not going to be real picky about that. If you want to get crazy and write feet here, that's fine, but some people get thrown off by that. Okay, so I really am okay if you leave it out. So lastly, we have c equals, again, I'm going to use the value of 3.14 times the 24, which is going to give me a final value of 75.36 feet. Again, it's feet because that's the units in the problem. All right. That is the circumference. That's the distance around the outside of the circle. So I didn't think I would do this, but I'll do it. I don't even know. Usually the arrows pop up on the bottom, like here, here, or here, that says subscribe now. Okay, so sure, I'll say subscribe. Anybody that gives me thumbs down, I'm taking 5 points off any quizzes you take for me. Anyway, good luck today, folks. I hope the video was helpful. And yeah, you can miss me till next time.